First of all, trigonometry is just studying we start off with right angle triangles, okay? In a right angle triangle, you have one of them is guaranteed to be 90 degrees, okay? And then it gives you an angle. So let's say this was angle A. Now, if I gave you three sides, 5, 4, and 3, can anybody tell me which one's the hypotenuse? The adjacent to angle A? Adjacent to angle A is number 3, and opposite is the one that the angle's looking at. So what's angle A looking at? It's looking at number 4. Okay? Now if I make angle B, guys, can anybody tell me what angle B is? The hypotenuse of angle B? Still 5. The hypotenuse of angle 4? Oh, sorry. The opposite of angle 4. The opposite of angle B. 3, because the angle B is looking directly at it. And finally, the adjacent of angle B? 4. Alright? Now, what we have next is rules of trigonometry, okay? Sine, cosine, tan. You learnt of Sohcahtoa. Okay? And it's not given to you in your tables that good. It's given to you in your tables using A, B, and C. And it's very hard to use. It's the quickest way to learn that off. Okay? So, what is Sohcahtoa used for? Sohcahtoa is used for two reasons. A, it can give you the length of sides, or B, it can tell you the size of an angle. So let's, for example, say I wanted to find the size of angle A. I might know how I can find the size of angle A. So write down either cos A, sine A, or tan A. Just out of interest, what is cos A? Opposite over hypotenuse, which is? Adjacent over hypotenuse, which is? 3 over 5 sine A, 4 over 5, and tan A, which is 4 over 3. Now, anytime you're asked for an angle question, and please be aware of this, every single time you're asked an angle question, the question has to end with cos inverse, sine inverse, or tan inverse. Anytime you're asked for an angle, that has to happen. Okay? So let everybody get out their what you do in your calculator, one of the biggest mistakes going in your leaving cert is there's no D at the top of your calculator. Does everybody make sure you have a D? D for degrees. Okay? Now, if you don't have that, and you're in the middle of the test, you're panicking, press Shift, Setup. What do you think will fix the problem? Number 3 for degrees. If I press number 4 for radians, you'll see an R in your calculator. Shift mode, Setup, back to degrees. Now everything works. Now, if I want to calculate what angle will cause a hypotenuse of 5 for adjacent of 3, can anybody give me the answer? So I press Shift, I cos inverse 3 over 5, and this tells me that the angle in question is 53.13. Everybody happy enough with that? Okay, so that is 53.13. If you did tan inverse or sine inverse, did you get the same answer? You do, because it's all angle A. Can anybody predict what would be the answer for angle B? There's two ways of doing angle B, isn't there? We can add them up and take it away from 180. So we could, in theory, do 180 minus 53.13, take away 90 degrees. Sorry, that's 533. Take away 90 degrees. And what we have is 36.87. What some other people decided to do, what did you guys decide to do? Huh? Just write down any function of B. Do you know what I mean by any function of B? Write down tan inverse, sine inverse, or write down sine, cos, or tan. So, example, if I chose tan B, what is tan B? Tan B is what? Opposite over. So, it's your 3 divided by your 4. What is tan inverse? B on its own is tan inverse 3 over 4, which is? Anybody? Anybody tell me? 36.869 or 36.87. Same thing we got last time. Alright. There's two main types of questions they have on this, okay? So, The main types of questions they have are basically they give you two sides, let's say 3 and 4. They ask you to calculate x. Anybody know how to do that? At this stage, everybody should have this one. Pythagoras Theorem. If I gave you this question here to the side, how would you do this one? The one on the right compared to the one on the left. What's the problem? It's not a right angle triangle. If it's a right angle triangle, you can use Pythagoras Theorem, as in x squared equals 3 squared plus 4 squared, x squared equals 25, x equals 5. However, if the question isn't a right angle triangle, some of you will do this anyway, but if it's not a right angle triangle, Pythagoras Theorem has no business. It can't be used. Is that alright? Now, there's two main types of questions, okay? The main types of questions can be like this. If I said this is x, this is 3, that's 60 degrees. Can you use Pythagoras Theorem to calculate the x value? Why not? You need two values. So how do you calculate that then? If you had two angles, you could take it away from 180. But you're not asked for the angle, you're asked for the... you can say that's 30 Mick, that's grand, but it still doesn't get you what x is. So anybody have any idea? Sohcahtoa, we're going to use tan, right? So we're going to say tan what? 60 equals x over 3. Somebody else could have came along and said tan 30 equals 3 over x. Both people will get the same answer provided they get x on its own. For this one, according to the 30, the 3 is the opposite. That's what the 3 goes on top. And according to the 30, the x is the adjacent, so it goes on the bottom. According to the 60, the x is the opposite, and the 3 is the adjacent. That's why it's upside down. Yeah, I get x on its own. You can do it for both of them. In this one here, it's going to be x equals 3 tan 60. On this one here, it's a bit more difficult. It'd be x tan 30 equals 3. X equals 3 over tan 30. Would somebody, Josh or somebody on this side of the room, will you do this one in the calculator? Will you guys do this one in the calculator? Tell me what answer you get. If it's not the same answer, we've gone wrong. 3 root 3. I changed the decimals. We got 5.196 for both of them. Okay, so long story short, it didn't matter which angle you chose, provided you were consistent with sine, cos, or tan. Was that a length or an angle question? That's a length question, wasn't it? Did we use tan inverse, sine inverse, or cos inverse at the end of the question? Hence, it was a length question, not an angle question. Okay, change this now to an angle question. And when we do an angle question, what we're looking at is we have a right angle triangle, if we're to use Sohcahtoa, and this is let's call that 10, call that x, call this 55 degrees. Can I in the class, oh sorry, no I'm wrong, call that 10, call that 8, call this x. Is anybody able to tell me the angle here? Now, I'll do one other thing. Get rid of this for a second. I want us to calculate the angle ABC. Which one's the most important letter in that? Nope. The middle one. It means A to B to C. Oh, sorry. So, angle ABC. My fault. So, angle ABC, which would mean you're going to call it this one here, aren't you? When you're using formula, are you actually going to call it ABC? Think of a letter, B, A, X, whatever. I always tend to use X's. Now, is this an angle question or a length question? Pay attention, guys. Come on, I guarantee we all won't know this. It's an angle question. Which function should I use, sine, cos, or tan? opposite and hypotenuse. According to the x, we're using the opposite and the hypotenuse, which is sine, because Sohcahtoa. Finally, we get sine x equals 8 over 10. Sine inverse that. Sine inverse 8 over 10. 53.13. Okay. That is everything you need to know about right angle triangles in whatever 6-7 minutes, okay? Not much else. Now, we then move on to non-right angle triangles, okay? We always have two options. Okay? So I'm going to show you two very similar looking questions with two very different ways of doing it. Okay? I'm calculating x, right? So okay. Would you agree that the information there seems to be very, very similar looking? Would you agree with that? Alright. Are they angle questions or are they length questions? They're both length questions. This means that sine inverse, cos inverse, and tan inverse not going to happen at the end of the question. Okay, you've recognized it as a length question. Now, arguably on the triangle on the left, we have access to full information, don't we? We can guarantee that the third angle is sorry, not 60, 50. How did I get that? We add the other two together to get 50. The one on the right, I can't guarantee that's a 20, and I can't guarantee that's a 50. I'm stuck where I am. Now, when you're using non-right angle triangles, what are the two main rules you're going to use? Sine rule and cosine rule. A over sine A equals B, side B over sine B. And then the other one is A squared equals B squared plus C squared minus 2BC cos A. The formula on the right is the cosine rule. The formula on the left is the sine rule. Are you happy enough with that? Now, what you're going to do when you're using the sine rule is you're always going to pick an angle. You pick an angle to use, or you pick the side you want, and you write down what side is opposite what angle. So, for the sine rule, I'm going to use it. I have to find out what x is. But if very virtue I have to find out what x is, I have to use 110. Because 110 is the angle that's looking at the x. Is everybody right with that? So I write down A represents the length, so that's x. X over sine, anybody? What is it? 110. Okay. The next piece of information I have to choose, are you looking? Is I have to choose another length. Is there any length in the question? Have to use 8. What angle looks at the 8? Huh? The 20. You can do it like this. You can start at the two of them, then work your way out, and then it meets at the both ends at the 8. That means the 20 is looking directly at that. Are you everybody right with that? Okay, so sine 20. Now, what is the step to getting the x on its own? The step to getting that x on its own. If I bring the sine 20 up, I'm bringing it towards the x. You can do it that way, but you'll have to move it back down again. The sine 110. Where does the sine 110 go? Up to the 8. This is called what? This is called cross multiplication. Cross multiplication only takes place when there's an equal sign in the middle. Otherwise, it's not known as cross multiplication. On a really basic level, if you had 1 over 4 equals 4 over 8, you happy with that? If I choose, would you agree that a half equals 4/8? If I move any one of these, what happens is it should still balance. So as an example, if I were to move the 2, where can I move the 2 to? Over to the 4. And what happens when 2 multiplies by 4? Equals 8 over, which is equal to 1. It's still balanced, isn't it? If I move the 8, where would that go then? If I move the 8, it goes to the 1. 8 divided by 2? 4. 4 equals 4. Basically, when you move something, it has to result in a balanced equation. If I were to move the 4 downwards, what would happen? It leaves a 1 behind it, because 4 is 4 times 1. And then it goes down to multiply by the 2, and you get an 8 equals an 8. If you aren't sure how to cross multiply, if you forget it on the day, write down two fractions that are equal to each other, move one piece at a time. If it continues to balance, you've done it correctly. If it doesn't balance, you've done something wrong. This fairly basic logic here applies to situations like this. What do I do with the sine 110? 8 sine 110 all over sine 120. Can somebody give me the answer for that one? Actually, and before you give me that answer, can somebody make a prediction for me? Please pay attention to this. This is how you control your answer before you even do the question. If you look at angle 20, angle 20 is tiny in comparison to 110. Would you agree with that? The angle of 20 is looking at a length of 8. What do you think the angle of 110 should look at? Should it look at a number like 6 or 7? It'd have to be a hell of a lot bigger, wouldn't it? So automatically, if you got an answer that's smaller than 8, you'd know you've gone wrong, and you'd know to look for a mistake. You got that? So, therefore, what's the answer then? 8 sine 110 over sine 120? 21.979. Okay. Now that leads me on to scenario 2. Scenario 2 would be, in a case like this, we only have two sides and one angle. And the angle is sandwiched in between the two sides. Is that alright? Is that okay, guys? Angle is in between the two sides. This is a clear indication you're using the cosine rule. Now, imagine you didn't know that, and you tried to use the sine rule. Okay? So let's imagine yes? Sorry? No. I'll do that in 1 second, yeah? Okay. So lads, Paddy offered me an alternative suggestion. What happens if the 8 and the x were to change position there? So this is 9. This is x. This is 8. Now, on existing information, Paddy, you'd get a... What would you get? X squared. You'd actually get a quadratic equation, a very messy quadratic equation. You won't be asked that. Okay, shh, excuse me. Lads, look at what's happening here, okay? And the problem is the 8, you'd have to set up like this, Paddy. You'd have to set up with 8 squared, because the only angle you know is 110, isn't it? So, and then once you choose what your angle is, what length you're looking for, the angle is automatically chosen for you as the one it's looking at. So I couldn't choose the x because I don't know what angle's looking at the x, and I would end up with two things I don't know in the same equation. While if I choose the 8, the 8 is looking at the 110, so that'd be cos 110. Now B and C represent the other two sides. It doesn't matter what order they're in. Lads, stay clued in. I'm not going to repeat myself again. Okay. A is x squared, you can say, for this one. B is 9 squared, and then it's minus 2 times b by c, which in this case would be 9 by x. And you see the way you're going to have a very messy quadratic equation when you multiply that out. You won't be asked that. Okay? But on the flip side, when you're given a bog standard one, like this one here, when you choose the angle, you automatically choose the side. Or when you choose the side, you automatically choose the angle. Now, guys, what you have here then is a squared equals b squared plus c squared minus 2bc cos a. Now, we're looking for the length x. So it's x squared equals what, guys? What, we're using the x squared on the left hand side because that's the one we're looking for. 9 squared plus 8 squared. After that, 9 bracket 8. Now, the handy thing about a length question using the cosine rule is that you just put all of this straight into the calculator. So if somebody could do that now, just put it all in the calculator. Okay. So what you get? Shh. What is it? 194.25. Lads, shh. Excuse me. What's the predictions? Should the answer be bigger than 8 and 9? Because it's the biggest angle in a triangle. So what is the answer when you square root it? 13.93. Okay. Now, that's all your length questions done. Okay? Length questions are easy. Now we're moving on to angle questions, which are considered the more difficult of the two. So, what we're going to do is just going to go back to the very beginning here. And back... Oh, jeez. Back at the very beginning here, before we did the sine rule. Here. Now, okay, guys. Now, a question like this, I'm going to change this to a 13, this to the x. In this question here, I'm going to call this 28. Okay, and I'm actually going to leave that angle out for a minute. Okay, and I'm going to leave that other side out. And oh wait, it's an angle question, so I actually got to do that. Yeah. Yeah, it's gone. Sorry about that. Actually, we'll need that to be 20. Okay. Alright, guys. What type of questions are the two of these? They're both angle questions, okay? Now, angle questions are different than the length questions. We'll start off with the sine rule. How do I know I'm using a sine rule? Two sides and one angle, and there's no sandwich going on. Okay? A sandwich means you know the length of one side, you know the length of the other side, and you know the amount of the angle in between it. Or you're looking for the angle that's in between both of them. There's no such thing as adjacent, opposite, and hypotenuse when the triangle is not right angled. So those words only exist for right angled triangles. But if you're talking about if you knew the longest triangle, is it? A long side. Yeah, you could go for the cosine rule then. Yeah, perfect. Now, lads, what you're looking at here is this. You can write down A over sine A equals B over sine B. Now I want to show you a little trick here that makes this a lot easier. You can cross multiply it and move everything around if you want. I can show you that way first. And failing that, I can show you a second trick that we use. If I said 1 over 2 equals 4 over 8, would you'd be happy enough with that? What happens if we turn both sides upside down? 2 over 1 is the same value as 8 over 4. Is that alright? Do you get the gist of that, guys? That when two fractions are equal to each other, you can turn them upside down and they'll still remain to be equal to each other. Okay, so I'll use that trick in a second. So I'm going to show you the way that most people do it. Most people do it like this. You write down the angle you're looking for. What side is it looking at? What side is it looking at? It's looking at the 28. The only other angle we know is the sine 20. And what's it looking at? The 8. Okay? Then your whole goal of the question is to get x on its own. What way does this question end? What's the last thing you're going to do here? Sine inverse. You're looking for an angle. It's locked beside the sine. Sine inverse has to be the last thing you do. So we're going to cross multiply. we're going to get 28 sine 120 equals 8 sine x. Remember, we just cross multiply. What's stopping the sine x from being on its own? The 8, so you bring the 8 underneath. Now, what is the only thing that can separate sine from x? The only thing that can separate sine from x, guys? Sine inverse. So, can somebody put that into the calculator, tell me what it is to about 2 decimal places? Come on, guys, get on it. Was it? Yeah, I'm getting that. It shouldn't be though. Just give me a sec with it. Ah, that's the problem. It's 20, not 120. Guys, the reason I knew there was a problem was because you can't sine inverse a number bigger than 1. Excuse me, guys, I've never managed to do this before, but apparently the side I chose, first time this ever happened, the side I chose is just simply too big to actually make a triangle out of. If you got the sine inverse 1.1, it's not going to happen. So it means that obviously using that angle and that length, you can't actually make that triangle, which I'm quite surprised with, to be honest. So we'll go again. So guys, what I'm going to do is I'm going to shorten that down to about 15, okay? So my fault, actually 14, make it smaller again. So, instead of 14, guys, so we're going to use 14 instead of 28. Okay, so 14 instead of 28. 14 here. 14 here. 14 here. Now what does that turn into now? So guys, sine x equals, what'd you say, 0.5? 598. Now, if we want to find out what angle causes the 14, what can we say it is? Sine inverse it. And what you get? What you get? Sine inverse 36.76. Okay, now the last thing we need to know. So lads, most sine rules work out great like that. What you could have done at the very beginning, however, if you wanted to use the upside down rule with the fractions, excuse me, you could turn the formula upside down right at the beginning. Remember saying that the fractions have to be the same even if they're turned upside down. Everybody remember that? And then what you could do instead is you can write sine x. The x looks at the 14. The 20 looks at the 8. And all you have to do this time is bring the 14 up beside the sine 20. Sine x equals 14 sine 20 all over 8. And as we know already, that's equal to, what's it, 0.59? 0.59 was it? 598. And then you can just sine inverse it that way, and you get the same answer. Okay, that's slightly quicker, but more or less same difficulty. Now, finally, the cosine rule, when it has the cosine rule, when you're looking for an angle. Okay, so get rid of this one here. We're working on the one on the right. In the length question, does anybody remember what we did in the length question? In the length question, guys, we put all of this into the calculator. We square root with the answer. It's very easy. In the angle question, because of BOMDAS, multiplication takes place before addition or subtraction. This part here is basically locked off till the end of the question. So what I mean by that is this. We choose the angle we're looking for. What's the angle we're looking for? So that's cos x. You've chosen your angle. What side is opposite the x? So that means you've chosen your sides. You choose the two of them first and you fill in the rest of the formula after you've done that. Okay, so guys, what do we get here is 8 squared plus 9 squared minus 2 times 8 times 9. Now, here's the problem. That's this number here, followed by 64 plus 81. Now, that's 144 cos x. Now, what did I say about that part there? It's locked off on its own for a minute. Move everything else to the other side. So what's 169 minus 64 minus 81 when you move over to the other side? So you're going to get 169 minus 64 minus 81. Any ideas? What's 169 minus 64 minus 81? Somebody has a calculator, right? 24, thank you. Now, guys, in the context of this question, what size is this angle? Is this the biggest angle in the triangle? Yeah? It is the biggest angle in the triangle, so it's going to be above 60 anyway. It looks like it might be obtuse, right? And if it's obtuse, we're expecting an angle above 90 degrees, okay? So we're expecting hopefully something above 90 degrees. Now, how does this question end? Ends with cos inverse. Why do we know this question ends with cos inverse? It's an angle question. Nothing to do with the letter. It's cos x represents an angle in this question. So bring the 144 underneath. Now, does the 144 change sign? Does it go into plus 144 or does it stay as minus 144? It stays as minus for the following reason. It stays minus because it's multiplication into division. It's not addition into subtraction. If you weren't sure about that, multiply both sides by minus 1. You could do it this way. And then you could divide by the 144 if you want. Both answers will give you the same amount. Will somebody cos inverse that number there? So what's it? Minus 24 divided by 144. Minus 24 divided by 144. That's it there. Shift cos inverse. Your answer. 99.6%, 99.6 or 99 half. Okay. Okay, guys. The only other thing I haven't gone through yet, it'll only be a second, is when you're asked to get this, the area of a triangle. Most of you know how to use this already. It'll only take a second. If I asked you the size of this triangle, what could you tell me? A half AB sine C. A half 8 times 7 sine 40. Then what? Just put into the calculator what you get. We know. 17.99. Okay. Now, how they'll trick you in an exam is they'll do something like this. They'll give you 7 and 8, and they'll tell you, look, this is that's 80. That's 60. And they'll ask you to calculate the area of this triangle here. What do you need to make that work? You need the angle that's in between the two sides, you know. So you'd have to add them up together and take it away from 180. And long and behold, it actually turns out to be 40, which is the same triangle we had in the first question. A half AB sine C. Okay, guys.